Hi, my name's Kevin from Leeds, and I'm here today to talk to you about Parfocality. It's a big word that we use a lot, but it's got true benefits to you, and understanding Parfocality is going to help you use your microscope better and make you more comfortable while you're sitting there. So Parfocality applies to a few things. First of all, the zoom system itself is designed to be parfocal. And what that means is that if I have an object in focus at high magnification, as I zoom down, it's going to remain in focus. And some of you may wonder, okay, why do I care about that? Well, low power pictures you're going to find are the hardest pictures to take. I know it's counterintuitive. You'd think it'd be easier to take a picture at 6x than at 102, but what you're going to find is the exact opposite of that. And it has something to do with an inverse relationship between depth of field and depth of focus, but that's another video. Just know that if you're having trouble taking your low power pictures, it's because your camera doesn't have the same depth to that image that you do with your own eyes. And it may look in focus to begin with, but then as you start zooming in, you see that the image is soft. If that's the case, focus on the critical area at a higher magnification so that you're very comfortable it's in focus. Zoom down to low magnification and you're confident that your picture is going to be in sharp focus for you. So that's one benefit. The other benefit has to do with the idea that in this particular microscope I have a primary viewing head, I have a secondary viewing head, and I have a camera. And I really want all of them to be in focus at the same time. And that's very easily achievable. Basically what we do is that we set our diopter numbers for the primary and the secondary observer and know that they're going to then have this be in focus at the same time as the video system and at the same time as the training binoc. Now, most manufacturers are going to provide you a focusing eyepiece. The difference here is that we've actually got a procedure. In fact, that's a separate video about finding your diopter number. And because there's little veneer marks, every day that I come in, I, for example, am a +1 and a +1. So I set my two marks to the correct position. And I know that when I sit there, the camera's going to be in focus at the same time as I am, and that if we have a secondary observer out on the other head, if they put in their diopter numbers, they're going to be viewing the same things in focus as I am. This diopter number is a refractive index correction. It's similar to if we're nearsighted or farsighted. We're just trying to compensate for each and every individual. The other added benefit to this is that when your diopter numbers are set, your eye is at rest. In other words, that means that your brain's not asking your eyeball to focus. And why do we care about that is the idea that if I have to sit here for any length of time, none of our muscles want to be held in one position for a long time. So when our diopters are properly set, it's as though we're looking out at the horizon and our eye is at rest. It's not trying to focus, it's just in its normal rest position. So again, parfocality of the zoom system and parfocality of the whole system is just another way that the Leeds LCF line of microscopes allows you to be a comfortable observer. Thank you.